Many times, harmonic motion problems take the form of word problems. So here's some examples. The displacement of a mass suspended by a spring is modeled by the function y equals 10 sine of 4 pi t, where y is measured in inches and t is in seconds. We're going to find the amplitude, the period, and the frequency of the motion of this mass. So, this is the basic form of y equals a sine omega t. I can tell from this that a is 10, so the amplitude is equal to the absolute value of a, which is going to be the absolute value of 10, which is 10. So there is the amplitude. Next, we're going to be looking for the period. And the period is found by doing 2 pi over omega. And in this case, omega is what's in front of t, which is 4 pi. So the period is 2 pi over omega, so it's going to be 2 pi over 4 pi, which is going to give 1/2. So the period is 1/2, and since the measurement is in seconds, this is 1/2 seconds. And last, we're looking for the frequency. And the frequency is found by doing the reciprocal of the period. So it is omega over 2 pi, and omega is 4 pi, so it's 4 pi over 2 pi, which reduces down to just 2. So the frequency is 2. Next, we have this question. A mass is suspended from a spring. The spring is compressed a distance of 4 centimeters and then released. It is observed that the mass returns to the compressed position after 1/3 seconds. We are going to find a function that models the displacement of the mass. So since this is starting in a compressed state, it's not going to be sine. So by default, we're going to be using cosine. So a cosine of omega t. So this is what we're going to use. That means we need to find a and omega. But from here we can see that it's compressed a distance of 4 centimeters. So that's its maximum that it's being compressed. So we can say that a equals 4. And then it's released, and observe that the mass returns to its compressed position after 1/3 seconds. So this is how long it takes to go back to where it started. So it's a period of 1/3 seconds. So the period is equal to 1/3. I'm going to drop the seconds because I just want the number. So 1/3. And we find the period by doing 2 pi over omega. And I need omega, so all I can need to do is just solve for it. So multiply omega over here, multiply the 3 over here, and I'm going to end up getting omega equals 6 pi. So now I have a, I have omega. Now I can plug both into my equation and get my final function. So I'm going to get y equals 4 cosine of 6 pi t. And that would be the function for this question.